Video number 15 plus, cosmic expansion or atomic shrinking. Hello everyone. One of the hard problems of modern physics, identified by the well-known astronomer Arthur Eddington, is to understand why the arrow of time that appears at the macroscopic level does not seem to have a microscopic equivalent. Presently, our physicists relate the irreversibility of macroscopic phenomena to Carnot's principle of entropy increase, which means that the level of disorder must increase with time. And it is true that the notion of entropy is a macroscopic concept, which does not make sense at the atomic level. However, maybe an arrow of time also exists at the atomic level. Indeed, the atoms, although fairly isolated, are exposed to occasional shocks from various wandering particles, cosmic rays and others, that travel through empty space and randomly collide with the most external electrons. If we represent the atoms by the old corpuscular model instead of the wave model of quantum mechanics, we can imagine that these random shocks play the role of a very weak dissipation, resulting after a very long time in the contraction of the electronic cloud, since on average the shocks push the electrons toward the nucleus. On the other hand, this idea does not seem to fit the current wave model, which Schrödinger, along with de Broglie and Einstein, believed to be only a first approximation of quantum reality. Around 1750, Leonhard Euler noticed that random collisions of celestial bodies with the particle constituting the ether could result in the collapse of the solar system, with the planets spiraling down toward the sun. Over a very long period, this is indeed possible, and even without assuming the existence of an ether, wandering matter from outside will be sufficient to cause the contraction of distances. The idea of a contraction of atoms over a very long time corresponds mathematically to the same model. For those interested in the model, the reference to my article on the subject is in the comments. Let us see which qualitative consequences could follow from atomic contraction. 1. The spectral redshift of distant galaxies could be due to the fact that in the past the atoms were larger, which increased the wavelength of the light emitted by the hot atoms, for example, because the angular velocity of the electrons was smaller. In such a case, cosmological expansion would no longer be necessary to explain the redshift. 2. Materials whose molecules are loosely bound, such as polymers, would contract more slowly. Some plastics would therefore give the impression of expanding compared to metal over a period of a few decades. This could explain the fatigue of certain electrical devices and why the batteries of some devices no longer make contact after 20 or 30 years. 3. It is well known that insects and plants from the Carboniferous period left gigantic imprints in the rock, leading to the belief that they were themselves enormous compared to today. Dragonflies with a wingspan of 70 centimeters, centipedes as long as 2 meters, horsetails 40 meters high. This could be due to the relative, and therefore apparent, expansion of chitin and cellulose compared to more compact materials, such as the stone matrix that gradually formed around them after immersion. Hence, Carboniferous gigantism would be a sort of optical illusion. If the hypothesis of a very slow atomic shrinking is based on simple and fairly plausible considerations, It is, on the other hand, very difficult to check. It seems that it can be only verified through its consequences. On the other hand, if we manage to establish it and make this study quantitative, which is likely to be particularly difficult for heavy elements, we might be able to use the obtained formulas to design electrical devices that age more slowly. There are always controversies between consumers and manufacturers of electrical devices regarding alleged planned obsolescence, which the manufacturers always vigorously deny. And this reminds me of a story told by the eminent mathematician Mary Cartwright, whose work included understanding the malfunctions of Galena radio sets. She had to, according to her own words, decide whether the fault is due to the manufacturers or to nature. Her calculations ultimately incriminated nature and played a fundamental role in the elaboration of the mathematical theory of chaos.